back. Today we're going to talk about the basic trig functions. The basic trig functions are what we've already talked about in the past: sine, cosine, tangent, cosecant, secant, and cotangent. We're going to look at them from a more specific standpoint when we talk about the coordinate plane. When we start to talk about standard position, we're talking about using the positive x-axis as our initial point. And so when I draw this, I'm going to attempt to draw a straight line. It's a little bit tough sometimes. Alright, that's not bad. And this is the x-axis, and this is our initial side, right? And being our initial side, it gives us a certain amount of comfort because that's where we always start from. And if I've got this angle here, and it's going to open up like this, I'm going to call this angle theta. So when we put theta in standard position, we're talking about this. This is our angle right here. Looks like a regular angle, except it always has that bottom initial side on the x-axis. We're going to look at the point xy. If we look at xy, and we don't know necessarily what it is, we don't know the scale here, so this is going to be x, comma, y. We're looking at what that actually means. The distance from the origin over to that x coordinate is going to be x units long, right? And the distance from the origin up to that y coordinate is going to be y units long. If you look at this, you'll notice we have a right triangle here. So no matter where that terminal side lies, we're always going to drop down a 90-degree angle and have a 90-degree right triangle. Well, if you're catching on to what we're doing here, we're making a right triangle so that we can find the hypotenuse. And the hypotenuse we're going to call length r. So r is the hypotenuse. X is one leg, and y is one leg. Together they form a right triangle. And if we look at this from a mathematical standpoint, when we get down here, we can start making some ratios with this. Let's talk about the trig functions. Can't see that. Let's talk about the sine of theta. The sine of theta, we remember, if we have an acronym here, SOHCAHTOA, sine of theta is opposite over hypotenuse. Remember this? Well, if we look at theta, the opposite of theta would be y, and the adjacent to theta is x, so that means that the hypotenuse, which we know, is r. And so the sine of theta is going to be equal to the ratio y over r. This is using stuff that we've already talked about. The cosine of theta is equal to the adjacent to theta. And if we look at our triangle once again, the adjacent is going to be x. And in fact, let me just label that. This is adjacent, this is opposite, and this is hypotenuse. And it's all in reference to theta only. And if we look at the adjacent over the hypotenuse, that's going to be x over r. Tangent theta. TOA is going to be opposite over adjacent. And if I look up here, notice I've already used the opposite, which was y, and the adjacent, which was x. These are the three basic ratios. Now, sine goes with cosecant. Secant goes with cosine. And so that's a little bit of a thing that can be a little confusing sometimes. So if we look at the other three ratios, let's start with cotangent so you can see how this works. The cotangent of theta is equal to the adjacent over the opposite, which is going to be x over y. So notice, all I had to do was flip that fraction over. Secant theta, also said SEC theta, is equal to the hypotenuse over the adjacent, which is going to be r over x. Notice I just flipped that ratio again, right? R over x. And the one that goes with sine is cosecant. So cosecant theta, it's abbreviated CSC, is going to be the hypotenuse over the opposite, which is going to give me r over y. I'm going to urge you to understand down here where it says x squared plus y squared equals r squared. That's what this is up here. X squared plus y squared is equal to r squared because it's a right triangle. And these lengths here, these distances here, are just the coordinates. So x comma y comma r are distances. And x and y are coordinates. And so let's look at example 1. It says find the 6 trig ratios for theta if theta is in standard position and the point -2, 3 is on the terminal side. Here's how I want you to lay this out. We know that we're going to need the 6 trig ratios. So if you look back in your notes, sine theta is y over r. I remember it as SEER, like Syracuse, S-Y-R. So sine, which is the S, is y over r. And that means that cosine is equal to x over r. And the tangent of theta, if you can't remember it, is y over x. You can look back up there. And we're actually going to be doing these, making them into numbers, and so I'm going to leave a little space. And then I like to match them up again. So the one that goes with sine is going to be cosecant. And you're going to see how easy this is because you just flip that fraction over. So the cosecant is r over y. The secant is r over x. And the cotangent is x over y. Now, key pieces to this. We need x, we need y, and we need r. Conveniently, watch how this works. Here's x, here's y. X is equal to -2, y is equal to 3, and I remember, of course, that x squared plus y squared is equal to r squared. So now I'm actually putting some values into this right triangle, all right? And so my side lengths are going to look like this. -2 squared plus 3 squared is equal to r squared. So this is 4 plus 9 equals 13. So r squared equals 13. So that means r is square root of 13. Leave it like that. Leave it like that. That's all you need. I don't need the decimal for this. Just leave it like that. So when I fill this in as square root of 13, watch how simple this becomes as a matching game. If sine is y over r, I'm going to have 3 over square root 13. This is the sine of theta. It's 3 over square root 13. Cosine is x over r, going to be -2 over square root of 13. And the tangent is y over x, so it's going to be 3 over -2. And then here's why I've paired them the way that I have. I can just flip it. So this is going to be square root of 13 over 3. This is going to be square root of 13 over negative 2. And this one's going to be negative 2 over 3. You just found the 6 ratios for that angle. That's as simple as it is. I think the most difficult part could be this calculation here, but that's just Pythagorean theorem. Understanding where those come from is part of the battle.